Good morning, dear students. So here I am again with a new class of online class in series of these online classes. Now we reach up to the end of the chapter surface area and volumes, and our last topic is volume of sphere and hemisphere. In our previous class we discussed about the formula of sphere and hemisphere. Once again I am going to repeat this. Okay, the volume of sphere, that is 4 by 3 pi r cube, and the volume of hemisphere, that is 2 by 3 pi r cube. Okay, now we already quite know about this sphere and hemisphere. Now we would like to see few questions on the basis of these formulas. Let's see first question. The volume of sphere of radius 3.5 centimeter. I'm just giving an example how to solve this kind of question. Okay, we need to find the volume of sphere. Now volume of sphere is 4 by 3 pi r cube. Pi obviously 20 to the power 7 until and unless it is your radius is not multiple of 7. Okay. Since it is 3.5 and 3.5 is quite divisible by 7. Okay, now see. First multiply the numerators and denominators, keep factors. Now here what we can do is 3.5 price. Okay, now see. Once you can cancel it with 7, then it will become 0.5. Now 0.5 is half bisected. Now 88 when multiplies to half, so 88 becomes 44 because the half of the 88 is 44. Now 3 is remaining at the downside and 3.5 square is still remaining. 3.5 square is 12.25. Okay, there is a small method to do so. That this is where the 1's 5 is 25 and the 10's you multiplied it with the one greater number, that is further 12. Okay, now again you can cancel it. 4 are 12, you don't need to cancel it fully, only up to 2 3 you have to cancel. 4 are 12, 0 are 0, 8 are 24. Okay, this is a 9. Now it will become like this, 44 into 4.083. Now we go to multiply this. Okay, now forget about this 3, you carry it with the 8 only. 44 8s are, now 8 4 is 32, so 320 and 32 will become 352. 35 will get carried, 44 0 is 0 and 35 5 will come, 3 only carries now, 44 4s are, now 44 is 116, 16, 176 and 3, 179, it will become like this centimeter cube approx, because approx value will 2. Okay, this is how you can get it. Okay, now see one hemispherical question we can see now. Suppose a hemispherical bowl is made up of steel of 0.25 centimeter thick. Now we are talking about a bowl which is 0.25 centimeter thick. This is the thickness. Okay. Now thickness can be described by r minus r, because the greater radius, if we subtract the smaller radius, this will result in thickness, which is gives us 2.5 cm. It is made up of steel given in question. Now what it says, the inside radius of the ball is 5 cm. Find the volume of steel used to make the ball. Okay, the inside radius, which is small r is given, small r is 5 cm. You need to find the volume of the ball. Okay, volume you need to find out. Now see, our object is actually hemispherical. Now in hemisphere, what is the volume? The volume of hemisphere is 2 by 3 pi r cube. Now they are keeping here value 2 by 3, pi is 22 by 7. Now see, remember, this is a hollow hemisphere, which means it is empty from inside. So what we are doing here, instead of r we are keeping r minus r, thickness 2. Okay, this will give us the exact volume of the steel used to make it. Now see, I'm keeping value here r minus r is given to us 2.5 centimeter cube. I'm keeping it here. Now see, we'll find it out. It will become 44 upon 7 is 21 and 2.5 cube. Okay, 2.5 are writing sides. Now see, since nothing will be cancelled with this stuff, so what I am doing here is first I am multiplying both this numerator. Now see, 25 close is 100, 25 close is 100, again 110 will carry forward, so that it will become 110. Again 2.5 will be 6.25, so 25 is 6.25, that's right. And here 21 is remaining denominator. Now again we multiply both the numbers. Now see, there is a decimal, okay, before 0. Okay, what I am doing here? I am just removing this decimal so that 1 0 will come down, and here I can also again remove the decimal, so 2 0 again comes down. Okay, as you can do what? You can multiply it with 10 times. Okay, this will also get interesting. I'll show you. See, what we can do here is we just play with that decimal. As you can write it as 11 into 62.5 by 21. Okay, no need to attach it also. You just multiply with the other number 10 times. Now again multiply 11 5 is 55, 11 to 25 5 27, 11 is 66 and 68. Multiply 21. Now you divide it by 21. 3 is 63, 5 will remain. 21 2s is 42, 15 will remain, and 21 7s are 147. 8 will remain. 21 now it will like comes like 32.7 centimeter cube approx. This will be the volume of steel actually used. And what else he asked in the question? He just asked the volume only. Okay, and the answer is also like it is 41.28. It is very less. I think we kept any value not correctly. Thickness is 0.25. It will be 2.5. That's why answer is not coming right. Okay, no problem. Okay. Let's see one more question. Okay, actually, accidentally I mixed up values in different questions. Let's see one more question. Hemisphere. How many bullets can be made out of a cube of lead? See now. There is a cube of lead, like a cube which is made up of a metal. A cube which edge measures 22 centimeter each. So 22 centimeter each of, because we all already know that in a cube all sides are equal. Now, so the bullet means 2 centimeter in diameter. Okay. Now see, bullet is like this. Okay, it is hemispherical and its diameter is 2 centimeter. So diameter is 2 means radius is 1 centimeter. So how many bullets we can make from that solid cube? Now see, we are keeping volume of cube. See, whenever we are comparing two quantities, remember this. From this whole cube we are making bullets. Okay, so the volume of the whole cube will be the volume of number of bullets. Okay, which can be made from this cube. So volume of this cube we are equal to n bullets, volume of bullets. Okay, which are hemisphere. Now see, volume of cube is side cube. And n into volume of bullet is 2 by 3 pi r cube because they are hemisphere. Now we are keeping values here. We need to find the n, how many number of bullets we can make from it. So n will come as a cube is 22 cube. 22 upon 2 by 3 pi 22 by 7 and radius which is 1 centimeter cube. We can cancel this 22 by this 22. From this 2 we can cancel this 11 times. And Nothing else. 1 cube will become 1 cube and 7 plus 21 will goes up. 11 into 22 will be 232. Okay, 22 ones are 22 and 22 ones are 22 and 2. Okay, so 242 will become, sorry, and 21 comes up and denominator is 1. Now multiply those numbers. 21 2 is 42, 22 1 2 is 84 and 2 is 86, 8, 21 2 is 42 again and 8, 50. So 5062 bullets we can make it from a single cube of side 22. Okay. Let's see one more question based on this hemispherical concept. Like one question we'll see now of a sphere when immersed in water. Okay, let's see. A sphere of radius 5 cm is immersed in water. Example 4. A sphere which is immersed in water and water is in a cylinder. Okay. Immersed means it is actually on the surface of the water and it actually implies some force on the water. And it says that its radius is 5 cm. So radius of the sphere is 5 cm. And the level of water rises 5 by 3 cm and the radius of the cylinder. Okay. Now water is filled in the cylinder. When we immerse this sphere, the level of water raises by 5 by 3 centimeter. This is the height given to us. Okay. Now see. Here one thing is not mentioned, but you have to assume it. The one thing which is not given is, it says that the radius of the sphere is equivalent to the radius of the cylinder. What we need to find out actually, assume we can having a radius of this cylinder as r centimeter. So let's assume the radius of the cylinder, that is small r centimeter. Now see, there is a physics law, Archimedes law. What Archimedes told that the volume of water replaced by an object which is fully or partially immersed in water is equivalent to the volume of the object. Means what? The volume of water replaced in the cylinder, okay, the rise in volume is equivalent to the volume of this sphere which is immersed in water. So what we are keeping here is volume of water raised in cylinder, that is equivalent to volume of sphere. Now see, volume of water raised in cylinder is, volume of cylinder is pi r square h is 5 by 3 centimeter and the volume of sphere is 4 by 3 pi r cube. Now first cancel this pi in the formula itself without keeping the value. R we have to find out. H is 5 by 3 given to us, 4 by 10 keeping here. R cube means the radius of the cylinder is 5. So that 3 will get cancelled with this 3 and 1 5 will cancel with this 5. So 2 power will be remaining. R square comes 4 and 5 square is 25 to the 100. Means R will come as 10 cm. This will be the radius of the cylinder. Okay. This is the question of the water and sphere that is immersed in water. Let's see one more question. I'm rubbing this. One specific type of question which is asked frequently in the examination, like this, which is of a level 2 question. Let's see one question like this. A cone and a hemisphere have equal bases. A cone and a hemisphere having equal bases. This is the base for the cone and the base for the cone hemisphere as well. Have equal volumes. So here what is given to us is volume of cone is equal to volume of hemisphere. Now see, one thing in common, that is radius. When bases are equal, that means the radiuses are equal. Okay, so the radiuses of both cone and hemisphere are equal. Find the ratio of their heights. We need to find the ratio of their height. Now you all know that the height of this hemisphere is equivalent to the radius itself. So we are keeping, on the place of height we are keeping radius only. Volume of cone is 1 by 3 pi r square h, and the volume of hemisphere is 2 by 3 pi r cube. Now pi and by 3 will get cancelled. R square h is equal to 2r cube. Now r is also equal, so we cancel the r also. H equal to 2r. If we call this r here, it will come like this. H by r is 2 by 1. This shows what? The ratio of height of hemisphere and cone. This is the height of cone, this is the height of hemisphere, which is 2:1. Okay. This is the relation or the ratio of heights of cone and hemisphere of equal base. Okay. One carved out question you can see now. Okay, volume, it will also comes in a volume question. There are a lot of volume questions in it of different objects. Okay, see. The largest sphere is carved out from a cube of side 10.5. Now there is a cube which is of the side 10.5 each. 10.5 centimeter cube is here. This is example number 5. We are carving out a sphere, the largest sphere which we can carve out from it. We need to find its volume. Okay. We need to find the volume of this sphere. Now before we are going to find out the volume, first we need to find the radius. Okay, the maximum radius of sphere. Let's see now. Now what we are keeping here is, see, the side of the cube is 10.5. Now see, whenever we are carving out one sphere, its diameter is maximized to the side of the cube. So we are assuming the diameter of the sphere will be 10.5. So that the radius of the sphere is got 10.5 by 2 or 5.25 cm. Now just find the volume for this radius. Understand, we can't move out from this sphere because we actually surrounded it by its walls, and the walls are apart from each other are 10.5, so that the maximum diameter we can assume for the sphere will be 10.5, so that the radius of that sphere we can carve out from that cube is 5.25 centimeter. Now we are finding the volume for this. So volume of sphere will be 4 by 3 pi r cube. I am keeping value here. Now 4 by 3 pi value here I am keeping 22 by 7 and 5.25 or 10.5 by 2 I am keeping 10.5 by 2 thrice. Okay, now just cancel it with each other. From this 2 2s are 4 will get cancelled. From this 2 we can cancel this 22. From this 7 we can cancel 10.5 7 under 7 and from this 3 we can cancel again as 0.5. Now see 0.5 is half or 11 into 5.5 and 10.5 when we multiply with each other it will come 110.25. Okay, now just multiply those numbers. 55 5s are. Okay. That is 275, 27 will get carried, 55 is 110, 27 is 137, 30 will get carried, zeros are zeros, so that 3 will come, 1 is remaining, 55 is 55 will 56, again we will multiply it, so it will come like this, decimal comes after 3 digits, so that 606.375 centimeter cube will be the volume of that sphere we can carve out. Maximum diameter equivalent to the cube. So this is how we can do the questions of carving out a shape from a different shape. Okay, one more question you can see. It is a higher order question of level 2. Exercise C. Question says a cone, a hemisphere and a cylinder stand on equal bases, have same height. A cone, a hemisphere and a cylinder have equal bases and equal heights. Mean this height and this cylinder height are same. Okay, and their bases are same means their radiuses are same. Now, show that their volumes are in ratio 1:2:3. You need to show their volumes ratio, which is 1:2:3. Let's see the find the volume of each volume of cone first. Okay, volume of cone will be 1/3 pi r square h. Okay, here 1/3 pi r giving r square h. Now since height are equal, so this h is equal to the height of this hemisphere, which is equivalent to the radius. So that I am keeping here in the place of h, I am keeping r here. So it will comes like 1/3 pi r cube. Okay, volume of hemisphere now. Now volume of hemisphere is 2/3 pi r cube. I am keeping it like this only because there is no height. Then volume of cylinder, which is pi r square h. Okay, now since here r is equivalent to that h, so I am keeping r in the place of h, so that it will become pi r cube. Now just find the ratio of these three. So 1/3 pi r cube ratio 2/3 pi r cube ratio pi r cube. Here no 3, so I am multiplying with 3/3, so that all 3 comes in the ratio. So that 1 pi r cube ratio 2 pi r cube ratio 3 pi r cube. Pi r cube will get cancelled, so that 1:2:3 will be the ratio of the volumes of all three shapes having the same base and same height. Okay, this is a very nice question to do in this segment of the chapter. So please do these questions accordingly. Volume questions of sphere and hemisphere, they are quite similar, and this is the only conclusionary exercises for volumes. Okay, so now we have seen the cube and cuboid surface areas and volumes, cylinder and cone surface areas and volumes, and hemisphere and sphere surface area and volumes. Okay, so there are total 6 type of questions in it, in surface area volumes. There are a lot more questions to do, wall painting or different HOTS kind questions, the comparative quantities or the conversions of shapes. So please practice it and do it accordingly. You can be good while doing so. Okay, we all are making mistakes because we all are human beings. I also make mistakes sometimes. So learn from your mistakes always and keep growing, keep improving yourself. Okay, thank you, take care, bye bye.